Hello guys, welcome back to the channel and to another video of our ArcGIS Pro tutorial series. In this tutorial, I will show you guys how to delineate watersheds or catchments with the help of a digital elevation model using ArcGIS Pro. I'm sure this tutorial is going to be pretty interesting for you guys because I'm not only going to show you how to delineate just one watershed like this, but I'm also going to show you guys how to delineate multiple watersheds as you can see here, depending on how you would like to have your subcatchments arranged based on how your river system happens to look. As a part of this tutorial, I will also show you how to derive the river network for your own study area. And the only thing that you need to get started with this is a digital elevation model or a DEM, which of course you can download completely for free from a number of different sources out there. So guys, without further ado, let's jump in and get started with the tutorial. And as you guys can see, I have already opened up my ArcGIS Pro project. And as I told you guys, the only data source that I'll be using to get started with this exercise would be my DEM, which you can see right over here. The name of the file is called elevation. It's a TIFF file. So what I could do is I could just directly drag this and drop it over here in order to load up my DEM. So let's go ahead and do that. Here, as you can see, it basically zoomed me into the correct location. And if I zoom out a bit, you would be able to see where exactly my DEM is located at. It happens to be right over here in the southwestern edge of the United Kingdom. Well, if you're interested in seeing the highs and the lows a bit more clearly, what you can do is you can basically click right over here and that'll open up this symbology panel. And from here, you would be able to select maybe a different color scheme, which can be a bit more representative when it comes to showing the highs and the lows. And if I invert the color scheme, now you can see that the low-lying areas in this bluish color and the areas with highest elevations in this brown color. And with this kind of a color representation, you're almost able to see where the rivers are supposed to be, which basically happens to lie along the lowest depressions across the entire DEM. Alright, so when delineating watersheds, the very first thing that we would like to do is we would like to go ahead and fill the sinks. And the reason why we do this is to basically eliminate small imperfections that are usually present in this kind of raster datasets. So in order to fill the sinks, what you can do is you can basically make use of the fill tool by heading over to analysis, and under tools, what you can do is you can basically go to toolbox, go to spatial analyst tools, and under hydrology, you will be able to see the tool called fill. And the input surface raster for this tool is basically going to be this raw DEM that we just loaded in. So if you just expand this button right over here, you would be able to see this elevation.tiff, that is this raster. And we can select the output surface raster as well. And in my case, I'm just going to leave the file name that I'm getting by default. And after that, we can simply click run. And just in no time, you would be able to get your filled DEM. And over here, if I were to compare this filled DEM with my original DEM, I can immediately see that there's a noticeable difference in the lowest value of the DEM, and in the newly filled DEM, that value happens to be 0, which previously was -1. And if there happen to be any imperfections across this entire DEM corresponding to any other elevations, this filling process should have taken care of those imperfections, and as a result of that, we have this filled DEM that we can work with. So what I'm going to do is I'm just going to deactivate this original raw elevation DEM for the time being. And the next major step when delineating a watershed that we have to follow is create a flow direction raster. So what we can do is we can basically go back a couple of steps, well, just one step, and under hydrology, you can again see there's another tool called flow direction. So this is going to be the second major operation that you're going to do. And the input surface raster for this now is going to be your filled DEM, which is this one. And I'm not going to change the output flow direction raster's name. And quite important over here, there are 3 different flow direction types that we can choose when it comes to executing this flow direction process. Now we have D8, MFD, and DINF. Now if you're not really familiar with each of these different flow direction types, I suggest you to click right over here and you would be able to get a small description of what each of these different flow direction types actually mean. For the purposes of this tutorial, I'm going to go with this D8 where the flow direction will be determined by the delineate method, where the flow direction will be assigned to the steepest downslope neighboring cell, and the corresponding direction coding for the 8 different potential directions of flows is like this. Alright, after that we can click run. And now what you can see over here is basically the same direction coding that you saw just a couple of seconds ago. And if I were to bring that back onto the screen, you can see that now all the cells that are colored in blue color, which has a direction coding of 1, basically can be interpreted as the cells where the flow direction happens to be towards the east, and all the cells with yellow color, in this case with the direction coding 2, happens to have a flow direction of southeast. And similarly, if we have, let's say, a direction coding like 64, that means the flow direction is towards north. So just make sure that you don't really confuse the color that gets assigned in this layer and colors that have been assigned in this direction coding image, because the color assignment over here is basically just a temporary color assignment. What you should be looking at is this number right over here, and if you compare this number with this direction coding image, you can basically get a good idea of what each of these pixels are supposed to mean. So if I were to just zoom in like this, you would be able to clearly see the flow direction of each of these different pixels. Alright, that's the flow direction raster, and next what we're going to create is the flow accumulation raster. So let's go back one step and open up the flow accumulation tool from here. And in order to run the flow accumulation tool, what we need as an input is going to be the flow direction raster, which is going to be this. And again, I'm not going to change the output label, and the remaining entries I'm just going to stick with the default values as well. And let's go ahead and run this flow accumulation tool right now. Alright, now you can see that we managed to create the flow accumulation raster as well. Now in the very first instance, if you're not really familiar with the concept of flow accumulation, especially when it comes to doing it through a GIS program like this, these numbers might not really make that much of sense to you guys. However, what you need to understand is that you can see that as we go towards the white area of this color scale, you can see that the number is increasing drastically. If you pay attention to the upper bound of this color scale, you can see that we have almost hit values that are in the magnitude of 10 to the power 6. And the number that you see right over here basically means the number of cells that got drained into a particular grid cell. Now, what do I mean by that? Well, if I zoom maybe right into this point, and if I head back to map and select this explore tool, and if I check the raster value of this particular cell, you can see the value that we get is basically 1,138,699. And what this number means is basically that's the number of cells that basically got drained in order for the program to calculate the flow accumulation at this particular point. And if you imagine this to be a river, as we go upstream, you can imagine that the area that drains into a particular point also reduces, which means if I were to maybe head back to a cell somewhere over here, the value that I should get should be lower than this. For example, let's say if I were to click right over here, you can see that the number that I get right over here is basically significantly lower. And alternatively, if I were to go maybe into this particular point right over here, which is supposed to mark a significantly large river, as I can see from this image right now, let's check out the pixel value right over here. You can see that the pixel value happens to be significantly large. And again, this is the total number of grid cells that basically drained into this flow accumulation point. And that's pretty much the way how you give a meaning to the values that you get to see in this flow accumulation raster. Now, by default, you wouldn't really be able to isolate the river system clearly because of the way how this color has been spread out. You can see that the grid cells with the highest flow accumulation gets marked in white color, and the grid cells with the lowest flow accumulation gets marked in black color, and everything in between following this gradient from black to white. However, if I right click over here and go to symbology, and instead of going with a stretch color scheme, if I were to go with this classify option, I would be able to do a manual classification. For example, instead of going with 5 classes, I'm just going to go with 2 classes like this. And maybe let's set up a different color scheme, basically something like this. And if you were to go with these default values, you can see what this shows is basically all the flow accumulations that are from 0 until this value, which happens to be 419,445, is basically marked in blue color, and everything starting from this number until this highest value, which again basically corresponding to higher flow accumulations, are being marked in this light blue color. So that's why we see this slight stretch of just a part of this river line. However, if we try not to be that stringent when it comes to marking the upper boundary of this dark blue color layer and bring down this value, we would be able to actually display lower flow accumulation cells as well, which means eventually not only the main rivers like this, but its tributaries will also start showing. Now, what do I mean by that? For example, let's say if I were to decrease this value to almost 200,000. So I'm roughly cutting it by half. That means now I'm asking the program to display all the cells which are having a value between 200,000 and this highest number in light blue color. That's why you can see that the river actually got extended a bit towards its upper part. And if you keep on reducing this value, you will start to see that the smaller rivers and the tributaries will also start to show as we reduce the value. So let me go ahead and reduce this value even further. Let's go with 100,000. And now you can see that we start seeing some tributaries. And if I were to maybe go with 50,000. Yeah, now you can see that we very clearly start seeing the river lines. If you were to zoom in like this, and what if I go with a value like 30,000? Yeah, now you can see that we started seeing all the grid cells which have a flow accumulation value ranging between 30,000 and 1,465,187, which happens to be the largest flow accumulation value. So everything between these two gets displayed in light blue color. So that's why again you start seeing a very detailed river network. And as the next step, before creating the watershed, what we need to do is we basically need to identify the point which you would like to use as the outlet of the watershed. So let's say, for example, if you picked a point somewhere over here, then your watershed will be created by taking into account the corresponding drainage area from all of these river reaches that are lying above this particular outlet right over here. But let's say if you decided to pick your outlet somewhere over here, then everything below that will be ignored and your watershed will be created only using the drainage area that feeds into this particular outlet, which should account an area above that outlet point. So when trying to delineate watersheds using ArcGIS Pro, the way to specify a particular outlet point is by creating a dedicated point shapefile just for that purpose. So that's what we are going to do next. So in order to create a shapefile, what I'm going to do is I'm going to first head over to View in order to open my catalog pane. And after that, I'm going to create a folder connection by right-clicking over here to my current working folder, which happens to be this, and inside that there's a folder called data. So I'm going to create a folder connection to this particular folder. And if you expand that data folder, you can see basically this elevation TIFF, which is basically the raw DEM that we started this tutorial with. And what I'm going to do is I'm going to right click over here and go to new and create a new shapefile. And with that, you can see that we got this create feature class window, and we will have to provide a name for our new feature class. I'm going to name it as outlet, and the geometry type, quite important, is going to be point. And the coordinate system, I'm going to use the coordinate system of my current map. Well, so far I've been working in this WGS 1984 UTM Zone 30 North coordinate reference system, but in your case this might be different depending on the geographical region that you're working in. But for my case, I'm just going to go with this, and after that we can click run. And you can see that it creates basically an empty point shapefile. If you right click over here and go to attributes table, you can see that we don't really have any records at the moment. And what we're trying to do is we're basically trying to add one record or add one point which signifies the outlet point. And to get started, you can roughly see that my river basically flows southwards like this, and I would like to create my watershed outlet point to be somewhere right over here. So what I'm going to do is I'm going to make sure that I have selected this layer, and after that let's go to edit, create. Well, we no longer would need this window, so let's close it out and click outlet, and make sure that you have selected this point option. And from here all you have to do is just zoom into your desired outlet location and make sure that you place the point right on top of this grid cell. It's quite important to leave the point on top of one of these high flow accumulation points and nowhere else, otherwise the program won't really be able to identify your flow accumulation point. So let's mark the outlet to be this point right here, and you can see that a new record got added to the attributes table. And after that, let's finish it up by saving our edits and just click on clear right over here in order to clear all the selections. Well, the point might not be that apparent to you guys because of the symbology, so I'm just going to click right over here and make sure that I select a color that stands out just a bit, like yellow in this case, and let's increase the point size as well. Click apply, and yes, sure enough, now you can clearly see the outlet point right over here. And once you have done that, what you can do is you can basically head over to analysis and open up the toolbox again. Let's get rid of this, and now we can go with this watershed tool, and as the input we need to provide the flow direction raster. So this flow direction raster is supposed to be this flow dir. Right over here we need to specify the input raster or the feature per point data. Well, basically what we created over here as this outlet point feature class is this feature per point dataset. Well, in our case we just happen to have one outlet which will generate the corresponding watershed that takes into account the drainage area corresponding to this particular outlet, which should typically cover this entire river system above this outlet point. So what we're going to do is we're going to basically specify this to be the outlet, and for the time being we don't really need to worry about selecting the per point field. Well, in the next part of this tutorial, where I'm going to show you how to delineate multiple watersheds, it's going to be quite important, but for this particular example, it's not going to be important just because we are dealing with one outlet point. So I'm just going to select ID as my per point field, and output raster, let's leave it to be the default name. And it's also quite important that you head over to environments and make sure that you expand your processing extent and select this entire extent of the DEM as the processing extent. Now you can simply do that by selecting any of these layers because all of these layers happen to have the same extent, so you can either specify the extent of the flow accumulation raster or the flow direction raster or the fill raster or basically the elevation raster. So I'm just going to go with this elevation raster, and that'll accurately capture the extent that we're supposed to have. And after that, click run. And sure enough, just like that, you can see that we managed to create the corresponding watershed that takes into account the drainage area which drains into this point as its outlet. So if I click right over here and go to raster layer, and if I adjust the transparency, now you would be able to see very clearly how the corresponding river system above this outlet point happens to be. As you can see, this right here seems to be the main river, which eventually flows into this particular outlet point, and all of these other rivers happen to be tributaries to this main river. Alright guys, so that's how you generate the watershed. However, just keep in mind that this watershed layer is still a raster. If you wanted to create an S3 shapefile out of this, you also can do that simply by using the raster to polygon tool, and we are going to do that just in a second. But before that, I'm going to show you guys what if you wanted to create multiple watersheds, maybe that takes into account drainage areas of these other sub-catchments as well. So that's what we're going to do right now. And if you can guess by now, the very first thing that I'm supposed to do if I want to increase the number of sub-catchments would be to specify the corresponding outlet points for each of those sub-catchments wherever I would need them. So that's what we are going to do right now. So what I'm going to do is I'm actually going to make a copy of this outlet shapefile by heading over to View, Catalog pane, and from here we can see this outlet.shp. let's right click over here and select copy. After that, click on data folder and select paste. And from here you can see that we got a new layer called outlet_1, which basically happened to be a copy of this outlet shapefile. And let's right click over here and rename this to be multiple outlets. Yeah, after that we can drag this and drop it over here. Let's change the symbology just to make it a bit more clear. Apply. And now what I'm going to do is I'm going to go back to edit and go to create, and this time I'm going to select these multiple outlets and I'm just going to add a few more points. So you can see that already there is one point right over here, and let's say I would like to have another subcatchment which uses this point right here as its outlet, and maybe another subcatchment right over here before it joins to this river which looks like a major river. I would like to create a subcatchment which corresponds to this river branch right over here, which means I would need to specify my outlet not at this point but a couple more steps before where this river joins this main river. So let's go ahead and place a point right over here, and just like that, maybe let's fix another point right over here, and yeah, why not maybe another point right over here. And finally, to delineate the subcatchment which corresponds to this river branch, let's add a point right over here again, not on the main river but before it joins the main river. Alright, so this is how I would like to specify my points, and after that click right over here to finish the process and save your edits and clear all the selections. Now if I go ahead and open up the attributes table, what you can see is you would be able to see a number of different points just like this. And now just because we have multiple points, it's quite important that we have unique IDs for each of these different points. Now if you look at this FID, you can see that we have by default an increasing sequence of ID numbers. For example, this first point is marked to be FID number 0, and the second point, which happens to be this point right over here, has the FID value 1. Well, you could either go with this one, or if you think that you would like to maybe modify this column to add your own sequential numbering, you could do that as well simply by clicking over here. You can add maybe this point to be ID number 1, and the second point to be ID number 2, and the third point to be ID number 3, ID number 4, ID number 5, and finally ID number 6. Well, all you have to do is just make sure that all of these points have different IDs and no two points have the same or unique ID. That's the only thing that you guys have to make sure. And after that, again, click save, click yes, and make sure you clear all the selections. And after that, if I exit out from here, let's head back to analysis and go to tools, and let's open up Watershed. And now what I'm going to do is I'm going to again use the same flow direction raster, which happens to be this, and this time 4 point data are given by this multiple outlets shapefile. And quite important that you select the ID field or any field of your choice that you decided to go with, which has its own unique numbering for each of the different points. In this case, again, if I were to reiterate that, because it's quite important, you can see that if you were to go with this ID column, you will have a unique numbering for each of the different outlet points. Well, in this case, coincidentally, the FID column also happened to have a unique ID number. However, sometimes things could easily get mixed up, so it's always good to create your own column and make sure that you by yourself specify a unique ID value for each of these different points. And the output raster, this time it's going to get called as flow 2 as opposed to this flow 1 watershed which we had previously. And after that, go back to environments, make sure that your processing extent basically matches one of these different rasters. I'm just going to go with the flow extent of the elevation again and click run. And sure enough, this time you can see that we managed to create the sub watersheds or the sub catchments according to this specification of these outlet points as we specified right over here. If you would like to see the river system underneath, what you can do is basically select this layer, go to raster layer, and you can increase the transparency again, and underneath you would be able to see the corresponding river lines that joins each of the different outlet point. Alright guys, now if you would like to create polygons out of these rasters, because keep in mind that still this watershed flow 2 layer is in raster format. So if you want to do things like maybe calculate areas of each of these different subcatchments, you will have to convert this layer into a polygon layer. So what you can do is you can simply head over to analysis, go to tools, and just search for the tool called raster to polygon, and select this raster to polygon tool. And your input raster is going to be this watershed flow 2 raster, which you can select right from here. And the field is basically going to be value in this case. And I'm going to name this outlet polygon feature as subcatchments. So it's going to get saved as a shapefile, and I'm going to have this simplify polygons ticked right over here, and then click run. And that way you can see that we managed to get this subcatchments S3 shapefile. If you right click over here and go to attributes table, you would be able to see, well, 7 different records which corresponds to each of the different subcatchment. And as an additional step, I would also like to generate these river lines that we saw underneath this layer as a separate polyline layer, which would also provide me the opportunity to sort of overlay the rivers on top of my subcatchments. And now let's see how to do that. So in order to do that, well, for the time being, let's deactivate this raster layer as well. And I'm going to use a tool called reclassify. And let's open that up. And what I'm going to do is I'm going to basically reclassify this flow accumulation raster, because when we changed the classification of this raster right over here through the symbology, that classification was just a temporary classification. Because let's say if you happen to just remove this layer and bring it back into ArcGIS Pro, this classification that we did will not actually hold. So what we have done over here through the symbology panel is basically a temporary classification just for visualization purposes. And what I'm going to do right now is I'm going to make this classification a permanent classification. So that's what we can do using this tool. So my input raster for this is going to be my flow accumulation raster, which is this. And we are going to reclassify the value field. And from here you can see that all the values from 0 until 30,000, I'm just going to assign a value called 0 for that. And all the values from 30,000 until this highest value, I'm just going to assign a value called 1. Alright, after that we can run this tool. Yeah, now you can see that we have a new raster with just 2 values in it. It's either 0 or, well, in this case it happened to be 2. And I'm not really interested in this 0 values. I'm only interested in these grid cells which have the value 2. Well, it might not be that clear in this because of the color differences. Let's go ahead and maybe pick a different color for this, like blue. Yeah. Now it's clear for you guys. So I'm not really interested in this pink area. So what I'm going to do is I'm going to use another tool called raster to polyline. And I'm going to make sure that I convert all of these grid cells which contain a value of 2 into a continuous polyline. So in order to do that, let's open up the toolbox again. And this time we need to search for raster to polyline tool. And the input raster for this is going to be this reclass flow 1. newly created reclassified raster. So make sure you select that. And here I'm just going to provide a file name called rivers. And after that, just make sure that you have set your background value to be 0 and yes, check simplify polylines. And after that, click run. And now you can see that we managed to create a new layer called rivers, which happens to be a polyline layer. And now what I can do is I can basically deactivate these other layers. And now if I activate the subcatchments, you would be able to see how the river system basically looks over each of the different subcatchment. Well, if you like, you could also perform a clip operation in order to get rid of these other layers, or you could just simply select and delete the unwanted river lines as well. So what I'm going to do is I'm just going to maybe perform a clip operation. And to do that, you can head over to the geoprocessing tools again and just select or search clip. And the input features for this is going to be my rivers. And I'm going to clip the rivers by the boundary of my watersheds, or in this case it's named subcatchments. The output feature dataset, I'm just going to name it as rivers underscore clip, which is totally fine. Click run. And now if you turn off these subcatchments for a moment, you would be able to see that the river line that we created using the DEM does tally sufficiently well with this river that you can see from the base map. Of course, there's going to be minor differences because that really depends on the type of the DEM that you use. If you use a DEM with a very high accuracy, then your river line is going to get traced exactly how it's supposed to be. However, for this example, I happen to use an SRTM DEM, which has a horizontal resolution of 30 meters. So it's quite normal. You would notice that some mismatches between this DEM generated river line and the actual river line that you might get if you were to use a base map like this. Alright guys, so finally, to make things visually pleasing, what you can do is you can just maybe change the line color to be something that's more representative when it comes to river. And for the subcatchments, you also can right click and go to symbology, and instead of applying a single symbol, you can go with unique values. And in this case, let's right click and check the attributes table to see whether we have a field that we can use for unique values. And sure enough, we can make use of this ID field, because when it comes to the records, you can see that each of these different records are actually unique. So let's make sure we click ID and a color scheme of your choice like this. And after that, click right over here, add all values. And that'll basically assign these different colors to each subcatchment. Alright guys, so that's about it. I hope the tutorial was clear for you guys. If I quickly open up the data folder by heading over to View, Catalog pane, you can see the different shapefiles that we also created right over here. We have the subcatchment shapefile along with the other shapefiles. So if you do have any questions regarding the process, just don't forget to add a comment down below. And if you like the tutorial, show your support by hitting that thumbs up button. And if you'd like to stay tuned for this kind of interesting GIS related tutorials, don't forget to hit that subscribe button as well. Thanks a lot for watching. I'll see you guys again with another tutorial very soon.